Children, today class we will be discussing about actually electrical energy and how can we measure the electrical energy. Then we will be discussing about electrical power. First, we will see what actual electrical energy and how can we measure the electrical energy. Children, we all know that energy can exist in a different forms. For example, sound energy, light energy, nuclear energy, potential energy, chemical energy, kinetic energy. So there are many forms of energies are there. And according to the law of conservation of energy, dear children, one energy can be converted into another energy. Actually, what does the law of conservation of energy say? It says that energy can neither created nor destroyed, but it can be transferred from one form to another form. This is what actually the meaning of the law of conservation of energy. But dear children, so though we have many energies, and electrical energy is the most desirable energy. And how can we convert this electrical energy into different forms of energy? Once again, let us see. Then after that, we will see how to calculate the electrical energy and what are its units also we will see. For example, dear children, let us take a filament. What happens when electrical energy is passed through the filament? It's very important. Dear children, in filament, for suppose in all these cases, let us think that through each and everything, we are like sending, let us say it's electrical energy only. We are sending electrical, means individually we are sending electrical energy. Now let us see how it is going to be converted. So when electrical energy, dear children, pass through the filament, what happens? It is converted into heat energy. So here through the filament, when electrical energy is passed, then it gets converted into heat energy. If the same electrical energy passes through the electric lamp, mainly will get light energy. It will get converted into light. Of course, some part again gets converted into heat energy also. But when we compare with that light energy, that heat energy is negligible. Whereas electric motor. So electric motor means, first you think, dear children, where can we use these electric motors? Electric motor we can use in a fan, in a mixie, in a grinder, in many places we can use. So where what happens, this electrical energy gets converted into mechanical energy. Why? That electric motor is able to do the work, that only we can call it mechanical energy. Okay, so it converts into mechanical energy. Whereas when electrical energy passes through the electrolyte, children. So for example, whenever we are doing electrolysis process, so through this, if current is electric energy is allowed to pass through it, what happens? It can dissociates that water into hydrogen and oxygen. Means there what is happening? So electrical energy is converting into what actually? Chemical energy. So during electrolysis process, electrical energy gets converted into chemical energy. When electrical energy converted through loudspeaker, dear children. So in a loudspeaker, what happened? So loudspeaker, it converts electrical pulses into sound energy. Children, did you remember microphone is quite opposite? Microphone is quite opposite, which converts sound energy into electrical energy. But whereas here loudspeaker, when electrical energy passes through the loudspeaker, what happens? Gets converted into sound energy. And here let us look at this coil around the soft iron bar. It's very, very important. This point we will be learning in actually electromagnetism. So what happens when electric energy passes through the coil around the soft, which is like which is around this soft iron bar. For example, here soft iron bar is there. So around this, what we can say, some coil is there. So if through this coil, if electrical energy is passed, then what happens? It behaves like a magnet. Means what here? Electrical energy is converted into magnetic energy. So dear children, so this is how actually we can convert electrical energy into different forms of energy. Now we'll see how to calculate the electrical energy. Dear children, in this look at here, a resistor whose resistance is R, and a battery, that is the power supply. It's a power supply. V is a potential difference across the power supply. Such a that, dear children, here through this circuit, I current can flow in a time t. In a time t. So this I current is flowing through the resistor in a time t. Let us take time. Let us take time t. Now, what is the electrical energy supplied by the power source? Now whose potential difference is actually means across its terminals potential difference is V. Now let us calculate that electrical energy supplied by the battery. Children, we know that already we have learnt what actually electrical potential means. Actually, what is the purpose of battery? What is the purpose of battery in the circuit, children? So it will do some work. For what it will do some work? To make the charges to flow from one point to another point. That work done only we can call it as a potential difference. Children, from the definition of potential difference, we know that potential difference is equal to work done by charge. We know this. So V is equal to W by Q. So children, from this can you write like this? W is equal to V into Q. Of course we can write. We can write here. So here this W only we can call it as actually electrical energy. So children, when charge and potential difference is given, then how to calculate the electrical energy supplied by the battery? That is a product of V into Q. So let it be first equation. Children, from the concept of electric current, we know that current I is equal to, what is the current, children? It is charge per time. So from this, can we write Q is equal to I into T? Of course, we can write Q is equal to I into T. Now, substitute Q value in first equation. Here you can substitute. Then what do we get? We get W is equal to V. Children, in the place of Q, we are going to write IT. So we will get V I T. So it is a second equation which we got. Here W is electrical energy can be calculated when potential difference, electric current, time is given. But children, from the Ohm's law, what is Ohm's law? Mathematical form of Ohm's law, V is equal to IR. Now let us see how we are going to use the Ohm's law in this case here. Children, we know that V is equal to IR. Let us see what do we get. Substitute V value in equation 2. In the place of V, let us substitute this directly. Look at here. W is equal to, it is in the place of V, we are going to write IR. So it is IR into IT. IR into IT. Additionally here, I into I will be what? It's a I square it is. So finally we get W is equal to I square RT. I square RT. It is another expression for electrical energy. But children, from Ohm's law, V is equal to IR. Can we write like this? I is equal to V by R. Of course, we can write as V is equal to IR, we can write I is equal to V by R. Now, in the place of I, we are going to substitute V by R. So, look at here, or else let us write here, substitute I value in third equation. Then what do we get expression for electrical energy? W is equal to V by R whole square, V by R whole square. Children, in the place of I, we are writing V by R into RT. So, V by R whole square will be how much, dear children? It will be V square by R square into RT. Here R square gets cancelled. Then what is left here? V square by R into T. So, that is W is equal to V square by RT is a fourth expression to measure the electrical energy. So look at here, W is equal to VQ, the first expression which we got to measure the electrical energy, and the next W is equal to VIT, okay, and third expression is W is equal to I square RT, and the fourth equation is W is equal to V square by RT. Okay, dear children. So this is how actually with the help of these formulas we can measure the electrical energy supplied by the source. We can calculate the electrical energy supplied by the source. It depends, dear children. It depends on the data. You cannot think which formula should I use. It's not that. It depends in the data. What is the data given? Depends on that only. You can use either of one. Okay, dear children. This is how actually we can measure the electrical energy supplied by the battery. Please copy it. Dear children, what are the SI units of electrical energy? So as it is the energy only, its electrical what are SI units are joules only. We will discuss about electrical power. What is electrical power? How can we measure the electrical power? And what are the units of electrical power? Children, it is also very important, but it is completely based on electrical energy only. Once you are able to calculate the electrical energy, it's very easy to calculate electrical power. Children, let us recall one's power definition which we discussed in work, power, energy chapter. What is power, dear children? The rate of doing work. The rate of doing work means this what actually we got. Power is equal to work by time. Power is equal to work by time. That's it. So same concept here we are going to apply here. So at what rate the electrical work is done? Simple it is. So here electrical power is equal to we can write electrical work done, work by time, or else we can say like this also. As any one electric appliance is connected to the power source. For example, dear children, here is, let us say here is bulb, let us say. It is connected to the one battery. It's a battery of potential difference V, let us say that. So that its resistance is R. And when you switch on this, here current I will flow in a time t. So at what rate an electrical, what we can say, appliance can consume electrical energy, or else at what rate power source can supply the electrical energy, that also we can call it as a electrical power. What is electrical power, dear children? So it's a rate of doing electrical work. It is the rate of doing electrical work. Rate of doing electrical work only we can call it as a electrical power. So if not, we can define it as a electrical energy consumed. At what rate an appliance can consume electrical energy which is connected to the battery of potential difference V is called as electrical power. Children, simply here electrical power is equal to what? Electrical work done by time. So P is equal to, as I told here, P is equal to W by T. So if you want to calculate power, you must know the various expressions to calculate the electrical energy. So before that only, just before only, we discussed various formulas to calculate to measure the electrical energy. So in that first one which we got, W is equal to expression also, it's not a problem. Now let us see, dear children. First, dear children, so let us see the first expression to calculate the electrical power. Children, electrical power is equal to, what do we know? Electrical work by, or electrical work is equal to the electrical energy spent. Okay, this is fine. So first expression, let us take it's a VIT. So it will be VIT by time. So here time gets cancelled. So here what do we get here? P is equal to V into I. P is equal to V into I. The first expression to calculate the electrical power. And second expression, P is equal to electrical energy by time. So next expression for electrical energy is I square RT. So it will be I square RT by T. So T gets cancelled here. So here power is equal to I square R. And here third expression, P is equal to electrical energy, that is V square by R into T by time, that is V square by R into T by T. So T gets cancelled, so that we get here P is equal to V square by R. For example, if you get W is equal to VQ, again we need same expression. Let us see that. So P is equal to VQ by T. Anyhow, Q by T is again I only. So we will get again same expression, that is VI only. So children, here these are the three various expressions to calculate the electrical energy. But here you have to understand, here when potential difference and current is given, we have to use this formula. And this formula used when electric current and resistance is given. And this formula we use to calculate the electrical power when potential difference and resistance is given. From this, look at here, as power is equal to W by T, electrical energy by time. So electric energy in SI system is measured in joules. So it is joule per second is a SI unit of power. This joule per second only we can call it as a watt. So W is a small, let us write small w, watt. Symbol can be capital letter. And we also use kilowatt, or if you want to measure the more amount of power, electrical power, then we also can use kilowatt. 1 kilowatt is equal to, children, 1000 watts. 1 kilowatt is equal to 1000 watts. And we have another units of digital from this expression. Look at here, it is potential difference into current. So from this, potential difference is measured in volt. So very important, volt into, and I is what actually ampere, it is measured in ampere. So it is also measured in volt ampere. Now dear children, we'll see. So with the help of this only, we are going to discuss the now commercial units of electrical energy. For example, dear children, here is, let us take, here is a bulb and is connected to the battery. Dear children, when this bulb is connected, in a circuit, means when it is operated, let us say it is electric appliance of power P. When this electric appliance is operated in a time T, then it consumes some amount of electrical energy. That how can we calculate? We can calculate like this. As we know that P is equal to W by T, we can calculate W, that is electrical energy, is equal to power into time. But dear children, here power is measured in watt. Don't get confused, it is a electrical energy here. Electrical energy we are representing with the letter capital W. Don't get confused, because here we are using same symbol to represent watt also. Okay, so here it is watt and it is a second we can use. But dear children, do you think that we can use electric appliance only seconds? So of course, if you want to measure electric energy in terms of seconds also we can measure, but it will become very negligibilities. So that's what electric energy minimum we will measure in hours only. So from that concept only here we have two, like we'll measure electrical energy in two ways. Look at here. So when power is measured in watt and time is measured in hour. So here we have watt hour. So watt hour is a unit of electric energy, because here kilowatt also unit of what? Electrical power only. So when you take a kilowatt as a unit of power, then it will be kilowatt hour. So try to understand here. Watt is a unit of electrical power, but watt hour is a unit of electrical energy, and kilowatt is a unit of electrical power, but whereas kilowatt hour is a unit of electrical energy. Means when you multiply with time, when power is multiplied with time, we are getting electrical energy. Now we will see what is a watt hour and what is a kilowatt hour and how they are related to the SI units of electrical energy. So very important. Okay, children, here let us take what we can say, here is power only, let us take here. Sorry, it's what a bulb is taken here, which is connected to the battery. For example, dear children, this is a electric appliance of power 1 watt. So it is an electric appliance of power 1 watt. If this is operated for 1 hour, if it is used for 1 hour, children, it might be refrigerator, anything you can take. For example, you have a refrigerator only, just you think. So just assume that its power is 1 watt. Just assume only. So when that electric, what we can say, fridge is operated for 1 hour, don't you think that it consumes some amount of energy? Yes. So that energy consumed by that electric appliance of power 1 watt in 1 hour. Children, I repeat once. The electric appliance of power 1 watt. So every electric appliance should have some power. If this electric appliance is operated for 1 hour, then the electric energy consumed we can call it as a 1 watt hour. 1 watt hour. Then 1 watt hour is how it is related to the joule. So if you want to know that, you must know one thing very important here. So watt is joule per second. This joule per second only we can call it as a watt, and 1 hour is equal to 3600 seconds, and a kilo means 1000. Dear children, they are the terms which we should know, so that only we can make relation between watt hour to the joule and kilowatt hour to the joule. It's very simple. So here, look at here, 1 watt hour is equal to how many joules, which we are going to calculate now. Children, 1 watt hour is equal to, so in the place of watt, I can write joule per second, whereas in the place of hour, what I can write here, 3600 seconds, 3600 seconds. So second gets cancelled. So here 1 watt hour is equal to 3600 joules. So this is how actually watt hour is related to the joule. Now come back to the kilowatt hour. First, how to calculate the kilowatt hour? Now by this time, let us take one huge electric appliance. Let us take a geyser which has usually more power. Let us take. So for example, a geyser of power 1 kilowatt. Try to understand it, children. Just assume we have a geyser and its power is 1 kilowatt. When that geyser of power 1 kilowatt is operated for 1 hour, then it consumes some energy, right? Why? To convert into heat energy. Yeah, that you leave it. What is the output? You leave it. So when that electric appliance of power 1 kilowatt is operated for 1 hour, it consumes some amount of electric energy. That electric energy only we can call it as a kilowatt hour. Now we'll see how kilowatt hour is related to the joule. So children, 1 kilowatt hour is equal, let us see, 1 kilowatt hour is equal to, children, kilo means what? Kilo means 1000. Okay, 1000. What is joule per second? Let me rub this, joule per second. And 1 hour is equal to, we can add 3600 seconds. So it is 3600 seconds. Children, here seconds gets cancelled. Then here this you will get 3600,000. So this actually we can write 36 into 10 power 5. But dear children, according to the order of magnitude concept, this can be written as 3.6 into 10 power 6 joule. So this is what actually 1 kilowatt hour, 1 kilowatt. Children, it's a very important examination point of it. It's very important. Even when we are solving numericals also, whenever they will ask us to convert the electrical energy from what kilowatt hour to joule, watt hour to joule, or joule to kilowatt hour. So we will use these relations only. Children, once again let us see what is a watt hour. The electrical energy consumed by the electric appliance of power 1 watt in 1 hour is called watt hour. 1 watt hour is equal to 3600 joules. What is kilowatt hour? The electrical energy consumed by an appliance of power 1 kilowatt in 1 hour is called 1 kilowatt hour. 1 kilowatt hour. 1 kilowatt hour is equal to 3.6 into 10 power 6 joules. Thank you so much. All the very best.